Okay, I'm just going to clean the bottom of this plate. The plate is actually very rusty. We need to get that out of the way so that we can arc weld it. And I'm going to use arc weld. I have a MIG and it's a 125 amp unit, but it's just a little bit too light duty, even using a gas mixture to weld anything this thick. So I'm going to go ahead and use a arc welding, a stick process on here. And I can't say it again too many times, buy quality tools. Sometimes if you know you're going to use a tool once or maybe twice, and if you throw it away, then that's fine. But if you're planning on keeping a tool for a long time, I bought this grinder when I was probably 17. This is a model 315 10580, a Sears 9-inch sander grinder. I'm now 60, and so this has been around for a long time, and it works just as good today as it did the day I bought it. The one thing I did have to do is replace the cord, because the cord over the years got pretty banged up, but the grinder itself works just as good as the day I bought it. So do spend the money, buy good tools, and they'll last you your lifetime. So what I'm going to do is clean this up. Now I've turned the plate upside down. So those are the 3 holes that I had drilled this way, and here are the 3 holes that were drilled that way. So I'm just going to clean this up so that when I put these in place to weld them, I'm going to have clean material to weld to. Now I'm sure many of you noticed my holy shirt, my go to religious shirt, because it's all holy. But when you're out in the shop and you're going to be arc welding, you're going to tear up your clothes anyway. So it's best to just use the stuff you really don't care that much about. So I'm going to go ahead and clean this with the sander. This is a 9-inch. I know everybody loves the little 4 inches. And by golly, you know, I do too. I've got a wall of them right up there. And each one's got a different head on it. Each one does a different job. Some are sanders, some are grinders. I pick those up wherever I find them. Some I bought new, some I bought on closeout, some I bought at yard sales. If you get it and you get it ready, it's a lot faster if you have the tool and it's just there ready for you to go. So we're just going to come back down here and we're going to clean up this plate. Let me get you centered. I got to get the camera lined up here. Alright, and I'm just gonna clean the plate. And this is a heavy duty cup wire wheel. Use a tool that's got the power to do the job. This is all the way down to nice clean bare steel, and there's absolutely nothing I need to do from here to it. That's ready to go. So I'll get the other pieces here cleaned up on a stationary, mounted on like a bench grinder wire wheel, and we'll get this bolted together, and I'll get the welder set. Okay, I have the pieces all put in place and we're ready to weld, but there's such an array of welding rods and processes, and how do you know what to weld what with, because there's so many different things. This is a resource put out by the Lincoln Electric Company. It's widely available. This particular one is the 100th anniversary published in 1995, but the process really doesn't change a lot. Sometimes there's a new rod or new material comes out, but for just about everybody here that's doing generic work with like A36 plate, which is what this is, and just putting general stuff together, you're going to find everything you need to know in this book. I think I paid $20–25 for it off of, on eBay. So what do we do here? So I'm going to come over here to section 6.2-1. This is welding carbon and low alloy steels with shielded metal arc process. Shielded metal arc, SMAW, shielded metal arc welding is stick welding with regular rods. So this is where we go to find that kind of information. So then I'm going to come back here to my last, to this bookmark. This is 6.2-4. We're going to be welding A36 plate, so that's A36. That's my material right there. Structural steel, 36,000 psi minimum. Pretty wide open here. It just says C note 1. So we'll flip the page over, and down here in note 1 it says, unless restricted by specifications, such as something that they would put on a drawing or whatever, use any E60XX or 70XX electrode for steel grades with 60,000 psi or less tensile strength. For steel grades with 60 to 70,000 psi tensile strength, use E70XX electrodes. So that means pretty much any 60 series electrode, and we will be fine. So I've dug around on my shelf, and I came up with this. This is, you don't need to know the name of who makes it, but it's made by Gibson Welding Products, whatever. It's E6013 rod. So this conforms to AWS SFA 5.1 E6013. So this is the same as Lincoln E6013 or Miller E6013 or whatever you're going to get at Home Depot E6013. 6013 is 6013. We're going to be using 3/32 rod. That's pretty small because we don't need a lot of power, a lot of holding. I'm only welding 1/4 inch material, and I really want to try to keep warping down to a minimum, so we're going to use 3/32 E6013. So now we know we can use that. I flip in the book back over here, and I look at typical current ranges for electrodes. This is page 6.2-2. I go to 3/32. I go over here to E6013, and that means that we can use between 45 and 90 amps of power on our welder. And if we go over here to this other section here on 60, let's see if I can find it. Yeah, okay, 6.2-9 right here. Under fill freeze electrodes, we can look at E6011 and E6013 right here. This electrode is used in place of E6012 for sheet metal welding, so you can do really thin stuff with it, where appearance and ease of operation are more important than speed. AC operation is excellent. So we're going to use AC current, and we're going to use 45 to 90 amps. So that's how we know. We can look it up here. We know that we're going to be welding with an electrode that's going to be compatible. We know how much current we're going to use. We know AC or DC, and we're going to be using 45 to 90. I'm going to probably set it at the higher end of that because it's a little easier to get the arc started, and I am welding a little bit thicker. I'm not welding thin plate. So I'll take you over there and we'll set up the arc welder. But before I take you over there, seeing we're already looking here, this plate's clean. I've got my material clean. You really can't weld through garbage. Got to take all the paint off, got to take all the rust off. It's got to be clean, minimum 1 inch from the weld zone out. So I could have just gone 1 inch out all the way around this and that'd been okay, but I had the wire wheel out. It was just as easy to go ahead, clean up the whole plate, get it ready to go. This is 1 inch, so you need this much room all the way around wherever you're going to weld, because what happens is that garbage that's on the plate, that whether it's paint or rust or whatever, will get sucked into the weld and it will contaminate your weld. So we want nice clean welds, and so we have to make sure that we clean all the way around, both pieces clean all the way around. And that could include going around the edge, like down here. It can actually suck off of this corner here. Material or dirt could actually get sucked up and around, so that has to be cleaned. So we're going to do AC welding, which is right here, AC welding, so I make sure this control is set to in the middle. We're going to do 45 to 90 amps, so that's white, so the white, well, the minimum here is 190, can't use that. This one is 5 to 48 amps, that's not the right one, so we'll come over here. This one is 20 to 230 amps, so that's where we want this. This is set in the middle. If I needed less, I could come over here like that, but that's where we need to go. So I move it back into the middle. It's not real accurate on how to set it up. Welding is more of a touch kind of a thing. So minimum is 20, maximum is 230. We're going to run 90, so we're looking at maybe 35% power. So we'll just dial this down to 35% range. Down here at 0 would be approximately 20 amps, and if I turned it all the way over to here, which is 100, that would be 230 amps. So that would be, like I said, down here at 0 would be 20, so we're going to go about 35, put it in the middle. We are on this particular welder, we've got high frequency off because we're not going to need it. We are on local control so that these controls work, and we're on local for the contactor. So this machine's ready to go. We're going to turn it on, and I will move all my cables over to the table. Okay, so we're getting our stuff here ready to go. These are just leather sleeves. You can get these like at Harbor Freight for a couple of bucks. They're really nice for protecting splatter, although the elastic leaves a lot to be desired. Regular arc welding gloves, go ahead and pull those on. I'm wearing a nice helmet. This is an auto darkening helmet. I do find that the Harbor Freight ones for 60 bucks works pretty well. I haven't had any burn in my eyes, and I'm pretty happy with it. So I've already pulled out some rods, laid them on the table here so that I can get my hands on them. I am not a professional welder. I do not play one on YouTube. Alright, so those are not going anywhere. I do want to make sure that they're pulled down tight, so I'm just going to put a couple, maybe one on this side here and one down on this side here. I don't want it shifting, I don't want that possibility. Clean the end of the rod. I did pull my cable up so that I get the slack so that the weight isn't pulling. You got to be able to be comfortable when you're doing this stuff. Alright, so what does that look like? Some of them are a lot better than others. Let me pull you in here. And that'll do what we need to do too. So typically, you know, they're not perfect, but they're going to work. So let's go ahead and get things cleaned up and ready for the next operation. Okay, so we're set up here ready to cut the material. The black line, because white doesn't show up very much on polished metal, but the black really does. We're going to do this with plasma. So this is the Hypertherm Power Max 45. It's one of their more popular units. It does everything pretty darn well that we would need to do in a shop this size. It's got several nice advanced features. The control panel is set up to tell us that the power is on, and we do not have any faults with the torch or with the air or anything else. This is our cutting control. This is current. The more, if I turn it down below 20, then it automatically turns the air on, but we're going to wind up using about 35 amps. Over here is the air pressure. That tells us we're in the middle, tells us we've got correct air pressure. The air adjustment is right back here, so I can turn this and I go one way, and then we're too low a air pressure, go back up the other way, that's marginal, and oh, we're good, and oh no, there's too much, and don't do that, there's too much air pressure. So we'll just back this down, and there we go, we're ready to go. Middle is normal cutting. On the bottom is for gouging, if you're going to cut out a weld or something. And then on the top it runs for interrupted cut. That's like if you're doing expanded metal and you don't want to have to start the arc each time you go through a little section. So, and then as you change your cutting process, your air requirements change. So for gouging, way too much air pressure, but normal we're okay, and in intermittent we're still okay. So we're going to use this. This is a replaceable or interchangeable cutting torch. This could come off. You could use this same machine on a automatic CNC. So we're saying that we're just a little low. I'm going to bounce the air pressure back up a hair, and we're solid to go. Okay, and all we have here is their torch. You lift the safety, pull the trigger, then you got fire. So we're going to take this, I've got it lined up so that the center of the cut is going to go right down the material. Air compressor will kick on. I'm going to be using air. So let me put you on the tripod and we'll get this cut. Now that the air compressor is shut off, I can talk again. One more thing. I did put a stand underneath just so that the cutoff is going to be supported. A little bit of work with the chipping hammer, and we will have a clean edge, and then that needs to be radiused with the grinder. Always soften your edges. That's just a mark of a craftsman. Leaving rough edges, sharp corners, that's just a mark of a butcher. So always take time, clean your edges, keep everything straight and clean. I'm going to take a moment here and chip this. Clean that up with a grinder, and we'll move on. Okay, now that I have these radiuses cleaned up, these corners, edges softened, I still have some sharp corners. I'm just going to clean those up here on the disc sander. I've been using the sander to polish and sharpen my soapstone, so that's why it looks like that. It doesn't hurt anything. Put this face down. And just radius these corners. Alright, we'll just soften these sharp edges here. And now we've got nice radiused edges. Everything's nice and clean. That's the mark of somebody that cares about their work, a craftsman, a tool maker. And here we go. The edges are all nice and smooth, done with a flap wheel. The whole piece is burr free, no sharp edges anywhere. And we're ready to go to the drill press and open these holes up to the tap size. I'll move over there and set everything up there. If you don't have a disc sander like I've got there, then that's fine. You could just as easily do the same procedure with a side grinder, 4-inch grinder, 9-inch grinder, whatever you have. But it's easier if you have the disc sander, but it's not mandatory to doing good work. Okay, next we move over here to the drill press, and we just take the 1/4-inch drill that we used on the top, put it straight down the hole. That way we know we're lined up. So I'm indicated cleanly into the hole. I'm using a piece of wood underneath the material. That way we know when we're through and we're not going to drill into the table like some kind of yahoo. And from here on out, all I need to do is drill different size holes until we get to the finished cleared tap drill, and we will do all the holes like that. Okay, that's the last hole. Just in case you hadn't been seeing it, this is LPS cutting fluid. It's really pretty good stuff. I really like it. It works really well, not just for tapping, but for drilling holes and any machining operation. It works on all metals, so it's really a nice thing to have. Okay, I ran into a little problem. I don't have a tap handle big enough to fit this tap, so I'm going to start it, power, and then I'll take it off, put it in a vise, and we will use a crescent wrench to finish that. So what I'm going to do is turn the power on and then turn it off just before the threads engage. That gets me started straight. I'm going to put opposite torque with my hand so that I'm not twisting the actual tap in the hole. Alright, just do that with all the rest.